up.
No, try it.
And
Sorry, yeah. Maybe I'd make it.
Where are you getting it? Okay, you guys are good to go.
We are Team Foxtrot.
Hey, quiet.
Ready? 1, 2, 3.
We are Team Foxtrot, and our project is an air quality detector. I'm Michael.
I'm Sean.
Keith. Jesse.
And so, our project will make an air quality sensor. Basically, the main sensor we're using for dust and what we use for the alpha is the amphenol dust sensor. We're supposed to use this as an alternative to the dial-less. Long term, we plan to incorporate other sensors such as the CO2 sensor. I think most people are using the Cozier, and we're probably going to end up using that as well. And it'll measure your temperature and humidity as well. Overall, the cost is so far for everything on the board, including the sensors, around $60.
Alright, the system overview. Basically, ideally our amphenol sensor is supposed to be detecting. It's supposed to be detecting large and small particles. That's what the PM10 and the PM2.5. The PM10 is the large particles and the small particles. Ideally, it's supposed to be able to access via wirelessly, either with XP or we also might be incorporating Bluetooth. It's supposed to be able to be accessed remotely, and so we can just leave it somewhere at some warehouse or whatever for a long time, and we can just read data whenever we want to, or we also might be storing data on the SD chip. Ideally, we want to have a pretty long battery life, as in maybe at least a few months.
This is the alpha prototype 3D model made by Sean. It's got all the components that we need, just the amphenol headers, serial prog headers, XP, and we're running on a few software right now.
You're supposed to play.
It's Team Foxtrot, and this is our GUI for the amphenol sensor. We begin by opening the COM port to the XP. Once we have been assured that the port has been connected, we can begin reading data by setting the read mode in either single read or continuous read. In continuous read, the GUI will read data every 30 seconds from our testing apparatus. The data will then be saved to a text file for documentation purposes. At any time, the user may plot the documented data within the GUI by clicking on the axes. The x-axis shows the day in February of when the data was read. The y-axis shows the dust particle concentration in thousands of parts per cubic foot. Between shortly after 4.5 and shortly after 5.5 days, the ramp is MATLAB's attempt to connect two data points, as no data was actually collected within those 24 hours.
This is our testing apparatus for our dust sensors. We have this funnel with a fan inside, as well as flour through the tube into the trash can over here. And as soon as the sensor detects dust, it sends the data over to the VSOC. And we also have the dials.
Nope.
So this is our power system. We have a USB and our LiPo battery feeding into the battery management IC, and it routes power from either source depending on the voltage level of the battery to our regulators and status LEDs. So this is our regulator. It's a 3.3 volt. We have our enable pin and battery source separated so that we can control when it's on and off. It routes to the PSOC 4 amphenol sensor and XP.
And we're running on 3.3 volts.
So this is our components we used in the PSOC 4 are a timer, a counter, and a UART to implement our reading and the overall timer. The timer calculates the overall sample window that we want to set and shuts everything off when it's when the set time is elapsed. Then the data is sent over XP using UART.
Yeah, right now our timing window is set for 30 seconds just for like testing purposes and stuff like that. So.
All right, so the one sensor that we're using, our low-cost one, is called an Infinal. It runs at low voltages. We're running at 3.3, which falls right into its range of operation. The one thing we have to worry about is humidity. If you run it in an environment that's a high humidity, greater than 85%, your data that you're going to start collecting is going to be skewed, which you have to compensate for. We're comparing our Infinal sensor to the Dylos. The Infinal is about $25 to $30. It's pretty low cost. The Dylos is about $250, so you have about a 10 times cost increase between the two sensors. The Infinal is nice. It gives two outputs, one for large particles and one for small particles that it reads in the air. The problem is the driver to implement it is kind of complicated, and it takes a lot of logic blocks on the PSOC in order to get somewhat decent readings. The other problem is that the readings that you get have to be calibrated. You have to scale it so that way you know what you're reading is valid. The Dylos is also a particle concentration detector, but it uses a whole different system internally, which is what drives the cost higher. But it's able to detect large and small particles, and the output of it is actually pretty accurate for all intents and purposes.
Yeah, one thing to note as far as like accuracy is concerned, the sharp sensor, a lot of times like, I mean the Infinal sensor, my bad. The like if there's not that many particles in the air, the line will never go low, meaning it will never really detect the particles in general. So I mean that's just one of the accuracy trade-offs that you get with the Infinal sensor as opposed to the Dylos.
All right, so for our beta, we're going to actually switch to PSOC 5. We have found that using our Infinal sensor has an Infinal sensor and our wireless communication has pretty much maxed out everything that's on the PSOC 4. In order to make our Infinal sensor more accurate, we're going to need some more UDB blocks, and we're also planning to add CO2 and temperature, and each of those is going to require another interface, communication interface, and those are also going to consume UDB blocks, which we currently do not have any on our PSOC 4. We also plan to include Bluetooth, which will be able to integrate into a phone app, so all the data that you collect on the device can be sent directly to an Android app is what I have developed so far. And that actually the app itself will actually log all the data, and you could send it to wherever you want. And then questions?
That was good. We're actually close for time, so let's just have the other group, and we can do questions all at the end. So.